Okay, let's dive into this, because we are looking at one of the absolute most mind-bending phenomena happening in our solar system right this very second. We are talking about the wild, extreme physics of planetary diamond rain. And what might sound like pure science fiction is actually a very real, incredibly complex scientific puzzle that researchers are finally piecing together. Welcome to The Explainer.
I want you to just take a second and imagine a bizarre reality where the weather doesn't drop water or snow, but instead drops precious shimmering gems. Sounds like something straight out of a fantasy novel, right? But this is a phenomenon that astrophysicists have long hypothesized to be happening right now on ice giant planets in our own solar system, specifically Neptune and Uranus. The conditions on these planets are so incredibly extreme that the very chemistry of the atmosphere behaves in ways we can barely even comprehend here on Earth.
Researchers paint this incredibly evocative picture of the whole thing. They predicted over thousands of years these diamonds, some of which could potentially weigh millions of carats by the way, might slowly sink through the planet's thick ice layers. They essentially assemble into a massive, thick layer of planetary bling wrapped right around the solid core of the planet. So we aren't just talking about tiny dust particles here, we are talking about a physical, relentless rain of massive cosmic gems slowly sinking toward the center of gravity.
So, let's get into the diamond rain mystery and unlock the secrets of Uranus and Neptune.
For decades, Uranus and Neptune have presented a bit of a cold case for planetary scientists. To understand why, you first kind of need to know how these planets are structured. Ice giants don't have a solid surface that you could, land a spaceship on. Instead, they just get denser and denser as you move toward the core. They're absolutely filled with this soupy mixture of water, ammonia, and hydrocarbons. And because of this massive density, as you travel deeper into the planet, the temperatures and pressures become unimaginably extreme. And it is exactly within this crushing, blistering environment that the conditions for our exotic precipitation are actually met.
Which brings us to simulating planets with plastic, moving from deep space right into the laser lab.
So, how do we study something that happens millions of miles away, under crushing pressure? Well, scientists at the SLAC National Accelerator Laboratory, using their LENAC coherent light source, along with colleagues at the European XFL in Germany, decided to recreate these planets right here on Earth. And this brilliantly illustrates the scientific method in action. In older experiments, scientists used pure hydrocarbons, which is just carbon and hydrogen, to try and mimic the planetary mix. It worked, sure, but it wasn't quite accurate because ice giants also contain massive amounts of oxygen. So in this breakthrough new experiment, they swapped out the pure hydrocarbons for PET plastic. Yes, PET plastic, the exact same stuff used to make the everyday soda bottles sitting in your fridge right now. It turns out PET has the perfect balance of carbon, hydrogen, and oxygen to simulate the chemical activity deep inside these ice planets.
To simulate the crushing depths of Neptune, the team took this plastic film and squeezed it inside what's called a diamond anvil cell. Think of it as basically a microscopic vice grip. Then, they blasted it with high-energy X-rays, heating it to a blistering 2200 degrees Celsius. By doing this, they weren't just creating high pressure. They were actually able to maintain it over longer timescales than previous laser shock experiments. They quite literally recreated the planetary interior in a fraction of a millimeter.
Now for the crazy part. Oxygen, a diamond's best friend, and the missing ingredient for these cosmic gems. This brings us to a massive turning point in the research. It turns out oxygen really is a diamond's best friend. Let's walk through how this builds step by step. When oxygen is present, it actually accelerates the splitting of the carbon and hydrogen atoms in that planetary soup. Because the oxygen takes the hydrogen out of the equation entirely, the carbon atoms are free to combine much more easily to form nanodiamonds. Then, these diamonds sink through the ice layers. The real shocker here, the oxygen allows these diamonds to form at significantly lower pressures and temperatures than scientists previously thought, which means diamond rain is likely happening at shallower depths and is probably way more common across the universe than we ever realized.
All right, let's look at solving the magnetic mystery and the dynamo driving the ice giants.
For years, scientists have been completely baffled by the off-kilter magnetic fields of Uranus and Neptune. Unlike Earth's magnetic field, which is nice and symmetrical, the fields on these ice giants don't extend neatly from their poles at all. To understand why, we have to look at what forms alongside the diamonds. Those extreme conditions create a bizarre state of matter called superionic water. Researchers often describe it as hot black ice. In this state, water molecules break apart. The oxygen forms this rigid crystal lattice, while the electrically charged hydrogen nuclei just float freely through it. Because you have these free-floating charged particles, this hot black ice is incredibly conductive to electricity. So the crucial point is how the diamonds interact with this superionic water. As those massive diamonds sink toward the planet's core, they don't just fall quietly. They drag gas and ice right down with them, violently stirring up those conductive layers of superionic water. This constant, massive churning creates a planetary dynamo effect. These massive internal currents of electrically charged fluid are exactly what generates the unusual asymmetrical magnetic fields of Uranus and Neptune. Think about that for a second. The physical rain of diamonds is literally driving the planet's magnetic shield.
But what about earthly applications for nanodiamonds? Let's bring the cosmos into the clinic and beyond.
We've talked a lot about the macro scale of planetary physics, but why does shooting lasers of plastic matter to us here on Earth? Well, the way we currently make commercial nanodiamonds is honestly incredibly brutal. We basically take a bunch of carbon and blow it up with explosives. It's messy, it yields totally unpredictable sizes, and it's just very hard to control. Compare that to the method used in this research, laser-driven shock compression of cheap PET plastics. This new method is far cleaner, much easier to control, and allows scientists to tweak the reactivity to dictate exactly how fast the diamonds form and how big they actually get.
And these cleanly produced nanodiamonds are absolutely vital for the future of human technology. Because we can now make them cleanly and predictably, we can use them in some incredible ways. We are talking about highly targeted drug delivery systems in the human body, ultra-sensitive medical sensors, and non-invasive surgical tools. And beyond medicine, these nanodiamonds are foundational for the next generation of quantum electronics, quantum sensors, and even acting as reaction accelerators for renewable energy. The applications are practically endless.
So where does the science go from here? Well, the researchers definitely aren't stopping at plastic bottles. The next steps involve using liquid samples that contain ethanol, water, and ammonia, which is essentially the exact cocktail that Uranus and Neptune are made of. By perfecting this icy planet recipe in the lab, they're going to get even closer to understanding the exact chemical dynamics of our solar system's ice giants and the thousands of similar exoplanets we are discovering out there in distant galaxies. We've traveled from the crushing depths of ice giants to a laser lab, blasting soda bottles, all the way to the future of quantum medicine. It really leaves you with a profound thought to chew on. If a piece of everyday PET plastic can unlock the magnetic secrets of Neptune and simultaneously fuel a quantum revolution right here on Earth, what other profound cosmic mysteries are just hiding in plain sight, perhaps even right there in our everyday trash? Thank you so much for exploring this with me today. Keep asking questions, and I'll see you in the next explainer.